The radius vector of the particle with time t varies as r equals at 1 minus alpha t, where a is a constant vector and alpha is a positive factor. Find the velocity v and acceleration of the particle as function of time. So if we are calculating for velocity, so we can go with the definition v equals dr by dt. So if position vector is a function of time, we write velocity as dr by dt. So if we are writing it as dr by dt, on differentiating, we obtain derivative of a t plus alpha t square with respect to dt. A is constant, and we can differentiate this function to obtain a 1 minus 2 alpha t. So this is the equation for velocity of the particle as function of time. So if we go for the calculation of acceleration, we are denoting acceleration with w over here. We write acceleration as dv by dt. Now when velocity is a function of time, we write acceleration as dv by dt, and on differentiating this equation, derivative of a 1 minus 2 alpha t with respect to dt, we obtain something like a derivative of a will be 0 because it is constant, and then we will obtain minus 2a alpha. Now the next question is asking us the time interval taken by the particle to return to its initial position. So if the particle is returning to its initial position, so it implies that the position of the particle r is equal to 0. So if we equate this equation to 0, we write at 1 minus alpha t equals 0. So from here we get t equals 0 and t equals 1 by alpha. So these are the two possible solutions which we say. So the time interval for which the particle was in motion can be written as 1 by alpha seconds. And now the question is saying the distance covered during that time. Now this is an interesting part over here. The distance covered during that time. So if we look at this particular question, so we say that the distance or the position vector was written as at 1 minus alpha t, and the equation for velocity was obtained as a 1 minus 2 alpha t. 1 minus 2 alpha t. So if we look at the equation of velocity, we can say that the velocity becomes 0 at a certain time, and then we calculate it as a minus 2a alpha t equals 0. So from here I can write a equals 2a alpha t, or we get t equals 1 by 2 alpha. So at time t equals 1 by 2 alpha, the velocity becomes 0. So over here I can say that we can consider velocity in two ways as function of time. One aspect is between t equals 0 to t equals 1 by 2 alpha, where velocity is positive and again becomes 0, and after which time 1 by 2 alpha to t equals 1 by alpha, when the velocity is negative and the particle is coming back to its original position. So we can consider it in these two ways. So if we wish to calculate the distance traveled in this time, so we are calculating it in this way: integration of v dt from 0 to 1 by 2 alpha, and then we add it with 1 by 2 alpha to 1 by alpha integration of v dt, and we basically take the mod value for both the equations. That is the positive side. You can understand it in this way. Let me give you one more explanation for this. Suppose I project a particle from the surface of Earth with a certain speed. So it will go over there and return back. So what we have done in this particular question is we have located this time when the velocity becomes 0. Now I am saying for this time the velocity is positive, and for this time the velocity is negative. So if we wish to calculate the total distance traveled, we are calculating distance for this part and distance for this part, and we are adding the two distances traveled, and we are taking the mod value to ignore the negative aspect which we might get in the question. So if we solve it this way, so we get the distance traveled can be written as a 1 minus 2 alpha t dt from 0 to 1 by 2 alpha plus integration of a to alpha t minus 1. We have done this to ignore the negative part dt from 1 by 2 alpha to 1 by alpha. So if we solve this integral equation, we get s is equal to a upon 2 alpha.